Okay, so pass out example 1, 2016, and it's from paper 1. So we've got triangle ABD is right angled at B. We've got our two angles denoted there, P and Q, and we want to find cos of Q minus P. So cos of Q minus P, you should recognise from your formula sheet. Okay, so relating it to the A and B. Right, so we need all that information. So I'm going to need to get that from this diagram. Always best to draw your triangles out. Put your information. Right, P is the smaller one of the two, so that's going to be 4 and 1. Q is the big one. That's still going to be 4, because that's this full bit here, but the height must be 3. So we're missing sides, we're missing our hypotenuse, so we're going to work that out. Going to go straight into the square root bit. So 1 squared plus 4 squared, square rooted, square root of 17. Then that one's easy, it's a 3, 4, 5 triangle. Right, get your information. So sine P and cos P. Okay, opposite SOHCAHTOA, opposite over hypotenuse, and then adjacent over hypotenuse. And then we're going to do the same here. So I had a cos first, but anyways, so adjacent, and then sine Q is opposite over hypotenuse. Right, so we need to sub all these into here and make sure you do it accurately. Right, so cos Q is 4 over 5. Cos P is 4 over root 17. Sine Q, 3 over 5. And sine P was 1 over root 17. Right, multiply them. Bring them together. This one's a show that. So you can see the answer there. It's similar to ours, but slight difference. The difference is our denominator has a third, but their numerator has a third. So how do we combat that? Think back to thirds, nat 5, rationalise the denominator. Okay, and remember, bottom line, it's the same as 5 times 17. Root 17 times root 17 is 17, so that's 85. And then you got your answer and you know you're right. Okay, so it's looking back to your addition formula, taking your formula, putting it in the correct letters corresponding to your formula, and then working your way through it.